So this is the Chem 1 lesson over solubility. So using solubility rules, figuring out whether things are soluble or insoluble. So first we got to cover phase notation. So when you write a chemical equation, we have been working on the basic form where you just have your reactants and you have arrow products, and you do need to worry about balancing that guy. And we've kind of left off there, but there's actually more you can add to a chemical reaction, and some of that stuff we're going to talk about is phase notation. So those phase notations are what you see up here. So S would represent solid, L would be liquid, G would be gas, and AQ means something that's aqueous, so it means that substance is dissolved in water. And as you guys see, most chemical reactions we deal with, a lot of times it's in water. Some reactions do need a little extra something to get it going, whether that's heat or energy of some kind. You may see something written above an arrow. You're not going to be responsible at this point for writing any of that. Just be aware that if you see that, that means. So states of matter. So elements are oftentimes color-coded on periodic tables, the one you see in our classrooms. Black would be something that's a solid on the periodic table, so you can see that most elements are solids. Liquids, we blew the periodic table. There's two elements. You've got bromine and you have mercury. And you are expected to know that water is a liquid. You'll laugh about it. It'll get messed up later. And gases are red on the periodic table. So we want you to know that your noble gases are, most of your diatomics are gases. And big ones like carbon dioxide, for example, we're going to expect you to know that that's a gas. Now, compounds. Compounds can be solid or aqueous. Most compounds are either one or the other, and you have to use something called solubility rules to figure that out. We'll talk about that in a minute. And strong acids are also all considered soluble. At this point in time, you don't need to worry about memorizing all of those acids. Just recognize that most of the acids you're going to see at this point in time are going to be soluble in water. So if something is soluble in water, that means that it dissolves. So if it dissolves, you're going to use the letters AQ after it. Remember that it stands for aqueous. If it does not dissolve, that would be considered a solid. So that would be when you see a precipitate formed. A lot of times. That would be your precipitate. You do have something called solubility rules. It's the last thing on the back of your periodic tables that we haven't talked about yet. And there's lots of different ways to organize whether or not things are soluble. Here's just one example. So if you notice, this table's first organized by negative ion. Remember, that's going to be the second thing in your compound, then your positive ion, and then it's going to tell you whether it's soluble or insoluble in the last column. So basically, you're going to look up your negative ion first. So the first one in your example of your notes would be silver nitrate. We can do that one together. So silver and nitrate. So you have to look up the negative thing first, which is nitrate. So we find that guy right here. Oops. You find that guy right here. So then if it's bonded with anything, it's considered soluble. So then if we look at something like calcium phosphate, which is your third example, you're going to have to look up phosphate first. So you're going to have to go through, find phosphate. Okay, phosphate's down here in this section. So now we're down here. And then you have to ask yourself, is calcium in the top line or the second line of your positive ions? If you take a second and look, it's not an alkali ion. Remember your alkali ions equals family number 1, right? Your very first column. If you don't remember that, you might want to write that down. So that means calcium is not, it's an alkaline earth metal. So it means we're going to be in the second line here, which means that that's actually not soluble. So let's see if we can find carbonate on here. Oh, carbonate's in that same section down here. And now we have potassium, which is an alkali ion. So we would say that that's soluble. Look up chloride first. It's in this section right here. So then we ask ourselves, okay, we've got silver right here. So it's not soluble, so we would write side. So we're going to look up hydroxide. Okay, we're in towards the bottom down there. And it was sodium, which is an alkali metal, family number 1. So it is sulfate. Okay, got sulfite down here. Oh, sulfate's got its own little section, and it was bonded with ammonium. So let's see, that would be any other positive ion side. So our hydroxides down here towards the bottom, calcium up there on the top, so it's soluble. So let's see our sulfate here. Sodium's not listed in the first line, so it would be 8. So we're in that same section, sulfate, but barium. Oh, barium iodide. We have to find iodine on here. There we go, found my iodine. And it's potassium, which is not listed up top. So it's the negative half of the compound first. Then you figure out which line. So that tells you what section you're on. Then look at the positive ion. That will tell you which line you're on. And that will tell you whether you're soluble or inside. Let's see, we've got to find chlorine on our list. Here we go, about in the middle. Zinc is not on the top line, so it's going to be our second line. It is hydroxide, and lithium is an alkali metal, so it's going to be soluble. On our list, okay, it's not on here, so we're going to have to look up any negative ion up top, and it is with lithium, which is an alkali metal, so it's going to be soluble. So nitrate up here towards the top with anything is going to be soluble. Phosphate's down here. Potassium is an alkali ion, so it's going to be soluble. Phosphate's down here. Copper 2 is going to be in that second line, so not those in on here. We said that, let's see, this guy was going to be aqueous, but that calcium phosphate was insoluble, so we would write an S after it. So the next one is potassium carbonate, so we would write AQ. Silver chloride, solid. Silver hydroxide, so which means if we put it in water, it would be aqueous, it would dissolve. Ammonium sulfate, soluble. Calcium hydroxide, aqueous. Sodium soluble. Barium soluble. And last, Ki, we would write aqueous. So you can see you don't have to worry about memorizing these rules. These will be given to you because you have access to your periodic table in your test. It's just a matter of breaking it down. Remember, CLO. So next we're going to practice writing out the molecular equation, including the states of matter. So more practice with prediction, but now we're just adding in those states of matter to it. So I've got zinc. So zinc is a metal. So we want you to know that metals are solids. So we can write blank here, zinc with an S after it, plus hydrochloric acid. So hydro in the front means it's just chlorine, and acids are aqueous. Draw ourselves an arrow. Now we can figure out what the products are going to be. So this is a single replacement reaction, which means zinc is going to try to replace hydrogen. I say try because we have to check our activity series to make sure zinc is more reactive. So we're going to take a second, check your activity series. Zinc's about in the middle, hydrogen is lower down, so zinc can replace it. So if that happens, we're going to end up with a compound between zinc and chlorine. We're going to have to figure out its state of matter, plus what's going to be by itself. Hydrogen is going to be by itself. Hydrogen by itself is a gas. Now, we do need to look up our zinc chloride to figure that out. It's a compound, so you have to check your solubility rules. So zinc, so over here, we're going to write AQ. So now we need to balance it and finish the word equation. So we're going to have to put a 2 in front of our HCl to balance out our chlorines, and that balanced that guy out. And so now we need to finish the word equation with zinc chloride. And hydrogen. Second one, perchloric acid and lithium hydroxide. So perchloric acid with an ic at the end, we're looking for perchlorate. If you look it up on your back of your periodic tables, we're going to have an H in the front because it's an acid. Perchlorate is ClO4. It's an acid, so we know it's going to be aqueous, plus lithium hydroxide. Lithium's +1, hydroxide's -1. We're going to look up that against compound, so it's going to be part of our solubility rules. We're going to look up hydroxide for AQ. And it's a double replacement, so those positive things are going to swap places. So we're going to end up with water, right? H and OH together, which is not aqueous, guys. It's a liquid. I do like to use a cursive L so it doesn't look like a 1. And then our other compound is going to be lithium perchlorate. Lithium's +1, perchlorate is -1, so we're going to have one of each of them. Balance and we'll finish out our word equation. Oh, I got one of everything. So finish it out by saying we're going to get water and lithium perchlorate. We've got one more example, copper 2 nitrate and potassium phosphate. So copper 2 nitrate, CuNO3 2, leave a spot to write our phase notation. Potassium phosphate, potassium's +1, but phosphate's -3. Same thing, arrow for its phase notation. Look both of these guys up. Copper 2, so we can put AQ there. Potassium phosphate. So double replacement, so copper and potassium are going to swap places, so we're going to end up with potassium and nitrate. And I remember it said anything with nitrate was going to be soluble, and then we're going to end up with copper and phosphate. Copper is +2 in this case, so Cu3, PO4, 2. We need its phase notation there. So means we're going to have to put a solid after it. Balance and finish that word equation. So balancing, I'm going to choose probably to put a 3 next to copper 2 nitrate. It's going to give me 6 nitrates. So I'm going to need 6 on the other side. So I'm going to need 2 K3PO4s. And that's got it all balanced out. Finish that word equation. So we're going to end up with potassium nitrate